Hey there, welcome back to the Andromedoom devlogs, episode number 8. If you'd like to skip ahead to the content, please check the timestamps in the description below. In this episode, I'll be showing you how I built the laser guide from the prototype that I showed in episode number 0. This is a laser that's rendered in real time. It points upwards, has a white color by default. If the laser is hitting a building or a shield, the color is red, warning the player not to shoot because you'll damage your own shields. And if the laser is pointing at an alien, it'll turn green, which means you have a good shot. And we're going to be implementing this with Godot's inbuilt raycast node and the immediate geometry node. Right, let's switch on over to the screen. Okay, so the first thing we do is on the player object, we'll add a child node of the type raycast. We'll enable it, and that's it. We'll attach a script. Call this aiming laser. Now let's export a field for the range of this laser, and let's set it to 6 units. And then on the ready function, we'll set the casting position of the raycast to 0, the range, and 0. This is a relative position. So as the player moves, the raycast itself moves, so it's always going to be attached to the player but casting upwards up to a range. Now, during the process function, we're going to be checking if the raycast is colliding with any object. The first thing we do is check if the raycast is colliding, and if it is, we update the color of the laser based on the collision, and we'll update the endpoint of the laser as well. And then we'll draw the laser. So first, let's check if there is a collision. So we'll get a reference to spatial, and we don't care about what type of object it is as long as it's a spatial, so we get its position in the scene. So we'll call this detected object. And so here we set detected object, and then on there we use the GetCollider function as spatial. Now remember, this script is attached to the raycast, so the GetCollider and IsColliding are functions, are methods intrinsic to the raycast class, the raycast node of Godot. So let's get a position for the end of the laser. Call it endpoint. By default, we should make sure for every process we make sure the endpoint is maximized, so up to the laser range. So we'll say endpoint is equal to the cast2 position. That's the maximum range of the raycast. And if there is a collision, we actually change the endpoint to the detected object's origin y. What we actually want is just to change the y position, not the entire vector, because the endpoint is going to be a relative position, and we'll also want to make sure this is global transform. How do we check what type of object it is? So we can do things like if detected object is alien, then we can do that. But what if we have aliens that don't derive from the alien class and other classes? We'll have to be creating a whole bunch of if statements. So there is a better way of doing this using Godot's inbuilt groups. So let's go back to the editor. Let's go to the building scene. This is the building scene. The node tab, and go to groups. Let's add a group called buildings. Now this is a member of buildings. And we'll go to our alien, and we'll add it to the aliens group. So now we've got two groups, buildings and aliens. And so we can say if detected object is in the group aliens, what do we do here? Update color. And if detected object is in group buildings, again, update color. Let's just terminate these lines for now. And then we draw laser. So how do we draw a laser? So let's create a method. So we'll draw a laser to the endpoint. We build meshes at runtime using the immediate geometry node. Let's create an immediate geometry and we'll call it laser mesh, and we'll instantiate it as a new immediate geometry. And in the ready function, we'll have to add child laser mesh. And in the draw laser function, we call the begin method and we select a type of primitive. In this case, we're just drawing a line strip. And then we add our vertices. So we add vertex and the position of the first vertex. Now the first vertex is just at the origin of this node, at the player node, so that's just 0. This is in relative coordinates. Again, we add a vertex here, and we add it at the endpoint. And then we call the end method. Now this will draw the mesh, but it won't be visible just yet, I don't think. Oh, indeed it is visible, but it is gray. So we need to override this material. Okay, so in script, let's create a new spatial material. Spatial material. And we'll just call this material. And we'll initialize it. And in the ready function, we'll override the material on the override property. Now in the inspector, let's head over to a mesh there. Because it's of the type geometry instance, there is a material override property on the immediate geometry nodes. So we can add this separately like this. It's that property we're changing. And we want this material to be emissive, so not to be influenced by any lights. So it generates light basically. And so we say material emission enabled is equal to true. And then all we do here is update the material dot emission color. So at the process, we default it to color white. Let's go to colors, white. There we go. And thus, if it's in the group aliens, we set material dot emission to colors dot green. And if it's in building, we set the emission color to red. Okay, let's hit play. I overlooked something. You've got to make sure you update your collision mask as well. That is the layers, that is the objects on these layers that the raycast will collide with. So we want it to collide with aliens and buildings, and we don't care about the player. So hopefully it works this time. Now you will notice something. that the laser keeps growing. It's because we forgot to do one other thing. Every time you draw the laser, you should delete all the old geometry, because you're redrawing it every time, so every process. So on the laser mesh, call the clear method, and that just wipes the slate clean. So at any given time, the laser will only be composed of 2 points. There we go. Much better. There was another error there, where once an object is removed, it will crash because of a null reference exception on the aiming laser script. So I believe we can fix this just by getting the collider, making sure it's not null. No more crashing. So I think it's good practice to, rather than use the IsColliding method, just use the GetCollider method instead, and check to see that the reference here is not null. Well, there you go, there's a dynamic aiming laser. Thank you for watching. I hope you enjoyed this tutorial and took something away from it. If you have any questions, comments, suggestions, please put them in that little box down below. Make sure to hit like and subscribe and hit the bell as well, so you can be notified for the future releases. I haven't made much progress from the last episode on the main project, so I won't do a devlog this episode. Instead, I'll leave you with a speed modeling video of the Velocitractor model that's coming up, and I'll see you guys in the next episode. Thank you for watching.